In this video, I'm going to define what a category is. First, we'll give our category a name, say C. And a category consists of a collection of objects. So first, note that I said collection and not set, because it's often the case that the collection of objects in a category is a proper class. But we still write, using set notation, that these are objects in the category. Often people will leave out the obj there and just say that x, y, z in C. And then for each pair of objects, we have a set of morphisms. So say between objects x and y in our category, we'll denote the set either as hom C from x to y, or we'll denote it as C x to y. I'm going to generally stick to this notation just for brevity. And we'll say that a morphism is an element of this set because it is a set. And we often write this as f from x to y, or we might write x to y, denote the f like that. We'll call this the domain of f, and we'll call this the codomain of f. All right. And now we want some our objects and morphisms, well, particular morphisms to satisfy a couple of things. So first we want a composition law. And that is, for each triple of objects, we want a function. So I'm going to write this x, y, z. And this is going to go from the set, which is the Cartesian product. Well, I guess I've already written it out. X, y cross hom y, z to hom, missed the C. Often people will leave out the C if it's clear from context what that should be, which category you're working in. All right, and that's going to take a map from x to y, a morphism from x to y, and a morphism from y to z. And in general, I will use the words morphism and map interchangeably. And it's a function, so it takes these to the morphism G composed with f. And I've left out this triple of objects here, and in general, I will actually just write this as GF and leave out the composition circle because things get a bit messy otherwise. All right, and we want this composition law to be associative. So that is, if I have morphisms such that H composed with G composed with F is well defined, then I should also have F composed with G composed with F being well defined. And they should be equal. They should be the same morphism. So this is associativity. And finally, we want identities. And that is, for each object x, I want a morphism, which I'll denote either 1x or idx, which is a morphism from x to itself, such that 1x composed with f is f, and g composed with 1x is g, whenever these are well defined. So f would have to have codomain x for this to be well defined, and G would have to have domain X for this to be well defined. All right, in the next video, we'll show some examples of categories, and this sort of very abstract video will hopefully start to make sense.